Morning students. Today we'll discuss last class we discussed about the drift velocity and related concept. Today there is one word. First is that mobility. It is a 1 mark question when it comes in the paper. What does by mobility? Actually mobility is denoted by mu and it is defined as drift velocity per unit electric field intensity. So we can compare it how the mobility is going to come. So drift velocity, you know that opposite to electric field intensity. So drift velocity per unit electric field intensity, and very simple, it is Vd by E. And if I put Vd value here, it will be E by m into tau. Last class we discussed it. So if you do it, it will be E tau by m. So this is drift velocity, and you know that tau is the average or the average relaxation time. Remember, average relaxation time between two successive collisions. So this is how we define the drift velocity. And remember that holes has less mobility in comparison to electrons. This will come in semiconductor. Hole and electron. Holes are actually vacancy of electrons. So mobility is a very important factor in the conductors or semiconductors. So we'll discuss about that. Now, today we are going to discuss next thing is the Ohm's law. Very important thing, and I know that all of you have gone through it. You have done the experiments in class 10, series, parallel and all these things. So this time also you have first experiment based on Ohm's law. All of you know what is meant by Ohm's law. The statement is very simple. The current flowing through a conductor, is directly proportional to the potential difference, applied across its ends, provided, remember it, the temperature, complete statement, and other physical conditions are same. So this is the current flowing through a conductor is directly proportional to the potential difference across its end, provided the temperature and the other physical conditions. So that means if I write V proportional to I, certainly the ratio of V and I is constant, that is R. That means V is equal to Ri. So that is Ohm's law. This is how we define. And I think what is R? R is resistance, and all of you know resistance is measured in ohm or denoted by this sign. So 1 ohm is 1 volt by 1 ampere. So we can define 1 ohm also by 1 volt by 1 ampere. So this is how we are going to define the Ohm's law. Now, Ohm's law is very important when we apply it in the different type of circuits. And for conductors, when we talk about the conductors, we are talking about conductors. So we know that the graph is this I and V. So this is the graph. And remember that this is the slope of the graph. And how we are going to get it? We know that they are proportional to one another, and their slope also represented. If I ask you here tan theta will certainly be delta I by delta V, but then it is 1 upon R. So R can be written as cot theta also. In in 10th, this voltage was on this side and current was on this side, so no problem. Both are proportional. And you remember Ohm's law circuit, this is a battery, and then there is an ammeter, and then there is a resistance across which you take what? A voltmeter, like this. Are you getting it? So simply is this, and this is going to like this. This will be the voltmeter. This will be ammeter. And then current flows from here, then get distributed here, then goes back to the ammeter. But then when you do the complete experiment, what do you do? I remember that this is the what? Voltmeter, then this is what? Ammeter, and this is what? Battery, then there is a key, then there is a RH. This is for your practical when you do the Ohm's law. We know that why RH was taken for different values of voltmeter. You know that different ammeter values you get for this resistance. So this is the Ohm's law. You'll do it in the lab. Okay, now here is a very important word, and that is that what exactly, if we apply the Ohm's law in conductor, then there is one word, and then we'll go with that is non-ohmic resistors. Now I think you remember these words. Those resistances which doesn't obey Ohm's law. Ohm's law. That means for them V by I is not what? Constant. So certainly there are some, say example, if I draw a graph for a semiconductor like silicon, you know that it is like this. So this is for a semiconductor, say this is for a silicon diode. So silicon diode is this. It's non-uniform. So non-ohmic resistor example, we know we have semiconductors, semiconductor diodes. Okay, so these diodes, they don't follow the Ohm. We have thermistors. There are certain example of what? Non-ohmic resistors, non-ohmic which doesn't obey Ohm's law. We have gallium arsenide diode. So these are the non-ohmic resistors. And very important graph I am going to draw for non-ohmic. Like for a complete diode, if I draw a graph, that is, this will be like this. Sometimes this is the graph. This is graph IV for complete diode. Okay, so this is a characteristic graph of diode because it is for positive and negative values of voltage and current. And then there is another graph. This is for diode, and there is another very important graph which I am going to draw is like this. Now you see this graph, it's very interesting. This is current, this is voltage, these all are non-ohmic. This is say in milliampere, this is in volt. This is also in milliampere because the currents are less, this is also in volt. So see, this is this graph particularly till this point. And then you see here, I am giving it 3 parts. Now this is non-linear region. And do you know what is happening here? It is a negative resistance region. Then there can be a word, can there be a negative resistance region? Yes, it is dropping down. And this is the behavior of a gallium arsenide diode which you see in remotes. The behavior of Vi for those diodes. So this is gallium arsenide what VI graph. So this can be a question in the paper, and this is for diode. So these are the non-ohmic resistors which doesn't obey Ohm's law. Even they can be the limitations. We can say these are the limitations of Ohm's law. Non-ohmic means limitations of Ohm's law, that it is not obeyed in gallium arsenide, it is not obeyed in diode. There are electronic circuits, semiconductors. So this is the graph. Okay, now there is a very important word. When we say Ohm's law, V is equal to what? IR. What is R? Is V by I. Then comes a word resistance. All of you know a resistance is represented like this. This is the symbol. Now resistance is what? If I ask you what is the resistance, now you say it is the property of the material or conductor to oppose what? To oppose the current. Now I think all of you know this resistance SI unit is what? Ohm. Okay. Now resistance, there are some factors affecting the resistance. Now we will talk about resistance. Okay. Factors affecting the resistance. Now if you remember that, say there is a wire or a conductor like this. Now this wire has a length and it has a cross-sectional area. Do you know R is directly proportional to A, R is inversely directly proportional to L, inversely proportional to A. So R is like this, and when you take out this proportionality, you get a constant rho L by A. So this is resistance. And what is rho? Rho is, you know, that specific resistance, or simply we say resistivity, electrical resistivity. So this is R equal to rho L by A. Rho is a constant for a particular material, and this is how the resistivity is defined. Resistance depends on length and A. And finally, when we say that if the length is going to increase, resistance is increasing. If area is going to increase, the resistance is decreasing. And there is a concept here that if length L dash, new length, becomes n times of L, do you know, by stretching, you stretch it, do you know what will happen? A dash area will become A by n when you stretch it. Do you know what will be the R dash? It will be n square R. Remember, this is very, very important concept. It happens while you are stretching a wire. If length is n times of L, A dash will become A by n. Then if you increase the length by twice, do you know, remember the question, or to the twice of the value, then the resistance become what? 4 times of it. So this is the factor affecting resistance. And we can do some 1-2 numerical based on, say, if the length of a wire of resistance R is stretched to thrice, then what happens to its resistance and resistivity? I think all of you know this question, very simple. If I give, do you know what is happening? L dash is 3L, so what will happen to A dash will become A by 3. I can write directly R dash will be 9 times of R. Resistance, what happens to 9 times of R? And resistivity remains what? Resistivity remains same. And I can do it because R is rho L by A. R dash will be rho L dash by A dash. What is L dash? 3L. What is A dash? A by 3. What it becomes? 9 rho L by A. What is rho L by AR? So it is 9R. So this is new resistance. So in this way we can find out. There was a question in Bohr, and I am going to give it example. And this question is that if the length of a wire is increased by 10%, then find the percentage increase in its resistance and resistivity. Now we know that resistivity remains same. Okay, so very simple how we are going to find out it. Length of the wire is increased by, so by means L dash will be L plus 10% of L. Remember by. It's not to 10%, it is by 10%. So L by, it will be 1 by 10 of L. It will be 11 by 10 of L. And that means A dash should be what? A by what? 11 by 10. So that is 10 by 11 of what? A. It should be like this. Why? Because I told you L dash is an L. So A dash is A by N. Volume remains same. So what will be R dash? It is N square what? R. So what is N here? N is 11 by 12. So 11 by 12 square is R. That means it is 121 by 100. So this is the value. R dash by R will be 121 by 100. And then percentage, the increase, I think all of you know, R dash minus R upon R into 100. It will be 121 minus 100 upon 100 into 100. Solve it out, it will be 21 by 100 into 100. The answer is 21%. Very important question, 2-mark question. Got it or not? This is, and resistivity remains what? Same. So this is how we deal with the resistance and resistivity. Okay. So got it? How we are going to directly, this is by 10%, then you know that A dash is A by N. We directly wrote it like this, then percentage increase. Okay. Now after the resistance, we have a word resistivity. Okay. So electrical resistivity. Are you getting it? Now electrical resistivity, we know that R is rho L by A. Certainly rho is RA by L. So this is resistivity. How you define resistivity? The resistivity, it is defined as the resistance of a conductor or a material having what? Unit length and unit what? Area of cross section. Okay. So this is how we define it in unit area. But the main thing is what? That resistivity remains same. Resistivity is same in stretching. When you stretch a wire, you know that the resistance changes but resistivity is same. So rho is RA by L. If I put the unit, it will be again what? R is ohm, area is meter square by meter. So certainly this is ohm meter. So this is how we define SI unit of resistivity, ohm meter. So this is the resistivity. Okay. there is very important thing that yesterday when we were talking about the drift velocity, there is a simple concept that what will be the current in a conductor. Now that is a small derivation, and yesterday we discussed that if there is a conductor and then there is a battery and then the electron will get drifted towards this side with which velocity Vd. This is the length of the conductor, this is the area of the cross section, and this is the battery potential difference. So we are going to find out, and there is a very important current is NeVd. This is the formula. How we are going to current? Say L is the length here, L is the length, A is the area of cross section, okay, area of cross section, Vd is the drift velocity, and here is very important, small n. Now don't say it as a number of electron, it is number of electron per unit volume, that is electron density. It is known as electron density. Remember, not number of electron. Some of the students, they get confused. So these are the things given. So all of you know how you are going to find out it. So that this electron will flow from as what I is what Q by T. What is Q? Any number of electrons into this T. Okay. And what is the small n? Number of electrons per unit volume. Volume of the wire is this. So n will be NaL. Are you getting it? So we put it here, NaAl E by what? T. And then what is the velocity? And this is what Vd. We are going to add the. So we know that the time is what? Distance upon velocity, L by Vd. So L cancel out, it goes up. We get a very important relation, NeVd. This is what? Current in a conductor. So in this way, there is a very important expression, I equal to NeVd. If I want to find out Vd, I can write I by NEA. From here also I can find out the drift velocity. So how the current in a conductor flows? It flows from negative to positive. The electron flows from negative to positive, while the current flows from positive to negative. And then you know that here very important one, N is what? Number of electrons per unit volume, Vd is drift velocity, A is area of cross section, L is length, I is Q by T, I N by T, and then you can find out this in this way. And if this is the current, we can find out the resistance and the current. Okay, so this is today we have discussed Ohm's law, current in a conductor, and some numerical. So practice it. Okay, thank you. Do the assignments and regularly watch my videos.